Watch the documentary and you'll enjoy it. Okay, so YouTube shout out to the world. Join us every day for calculus. We are working on example 2 right now. We're picking up from yesterday, and I want to show you guys, would you like an easier way to do this problem? I'm going to show you the easier way. Okay, you want the harder way? Okay, all right. So you guys notice that this is what the function looks like. We talked about that yesterday, and I just want to review with you. What did we say was the x value for the point on that line? 8, and what was the y value? How did we come up with 3? We plugged it in. Then what I did is I went over here and I said, I want you guys to find another point, plug in 9. And then I want you guys to do 8.5. I want you guys to do 8.1. I want you guys to do 8.01, right? And we went down here. We came with 0.16 and 0.1666, and we saw that the trend was there. It would be a pain in the butt if all of you guys every time had to punch in 4 or 5 or 6 different values, wouldn't it? So I'm going to show you a shortcut. Instead of plugging in, say, 9 or 8.5, you're going to plug in, get this, you're going to plug in x. If I plug in x to this, what is the output? Square root of x plus 1. Thank you, Kelvin. Let's now figure out the slope. Y sub 2 minus y sub 1. What is my y sub 2 value? Minus, what's y sub 1? 3 divided by x sub 2 minus x sub 1. That is my slope function. So what we're going to do is we're going to plug in 9 and 8.5 and 8.1 and 8.01 right on our calculator. So I turn my calculator on. I go into y equals, and I have the square root of x plus 1 minus 3. Now, right now, if I hit the division sign, that's going to be an issue. I'm going to have to put some parentheses around this whole thing. So we're going to put parentheses there and parentheses there. So I have the top divided by, now on the bottom, we're going to do x minus 8. Everybody see that that's my slope function? I go to my table, and what x value am I approaching? I want to find the line tangent at what x value? So what values are close to 8? Sure, we'll start with, say, 8.5, and then 8.1. Now, Michael was entirely correct when he said 8.01, but I want to see a trend. If I choose one value, I'm not seeing a trend. We're going to do it one more time, 8.001. And are you convinced that it appears that the slope is 0.166 in that situation? Yeah, so that way we didn't have to do a lot of calculations. We used our technology for that purpose. Let's do the same thing for this example right here. Find the equation for the line tangent to the curve, y equals tangent of x at x equals pi over 4. Okay, we're going to find that slope. First of all, I'll determine a point on the line. The point on the line will be what for the x value? Pi over 4. And I want a y value. How do I come up with the y value? Plug in pi over 4 to tangent. What's the tangent of pi over 4? It is 1. So you're working in radians. For calculus, you will always work in radians. Always. Okay? Just stay in radians. Okay? So we've got pi over 4. And when you type it in, you get 1. Or the tangent of 45 is 1. If you remember that. Well, that's my first point. I would like to come up with a second point. Second point will be x. What's the y value? Tangent of x. So let's write an equation for the slope. Tangent of x minus 1 over I'm going to now find the slope by going to my calculator. parentheses, tangent of x, parentheses, minus 1, parenthesis, divided by x minus pi over 4. Your calculator will be in radians all year. There are two exceptions. Number one, your first exception is when you're doing your entrance worksheet, because there's stuff on last year's material that you would use in radian or in degrees. And then there's one word problem we do this year that we're going to convert to degrees. That's it. Okay, so what value am I approaching? I'm approaching pi over 4. People often wonder, what do I plug in? You're getting close to pi over 4. Well, let's first figure out what pi over 4 is. And notice, if you actually plug in pi over 4, why do I get an error? When I plug in pi over 4, why do I get an error? You have 0 in the denominator. So I have to plug in things close to pi over 4. Let's start by plugging in 1. Now what? .9, okay. .8, okay. .79. 0.7855. What do you think it's going towards? I would say that it's very clear right now that it's trending towards 2. So we would say that the slope is 2. Yes. You go off the, no, you go off the x value. We're approaching pi over 4. So the tangent line, we're going to write that equation. The slope is 2, and the point on the line is, that pi over 4, 1. So therefore, we have y minus what? 1 is equal to m times x minus pi over 4. So y minus 1 is 2x minus pi over 2, and I'll add the 1. Y is 2x minus pi over 2 plus 1. Because I'm an excellent mathematician, I will always find a way to check and verify my answer. I'm going to verify my answer by going to my calculator. I want to make sure that that tangent line is tangent to the graph. So what do I put in for my graph? Because it's not this thing, is it? What's my graph? What's my function, my original function? Tangent. So I have tangent of x. And then I put in the equation for my line, which is, as you guys said, 2x minus pi over 2 and plus 1. And if I go to my window and I adjust things properly, maybe you recall that this is the tangent graph. Does that look familiar now? Yep. And here's the line. Does it look like it's tangent at pi over 4? Sure does. That's pretty good check right there. So you don't have to be real exact when you draw your graphs for your assignment, but just make sure that you show that you checked it and it looks like it was tangent at that spot. That will be sufficient enough. You verified that it is tangent. Now, that's going to conclude our lesson for today. You are going to practice this 6 problems on a worksheet. The answer key is posted for you.